So thanks for showing up. You must be the real devotees on a rainy night. So we have three speakers tonight. I'm going to do a quick talk about just how to do OpenAI RAG and how to do a custom agents RAG. And then we're going to have two more speakers. So let me go ahead and kick it off. So the usual slides about Zilliz, founded in 2017, headquartered in Redwood Shores. Zilliz is the company that maintains Milvus, the open source vector database project. And so a lot of people ask, what is Zilliz? What's Milvus? So similar to, I think a lot of companies do this where they have a structure. The open source project is the open source project, and then the company that maintains that open source project. So you've heard this many, many times about AI hallucinations, which is the reason why people are why RAG is really taken off as an introductory way to bring your own data into the generative AI work cycle. And part of the reason is because you'll see when you type in something, you could possibly get a hallucinated answer. So I recently did this on Bard with Gemini. List 3 politicians born in New York City. Seems like a simple question. And the first response is Hillary Clinton. And of course, if you go to Wikipedia, you see she was born in Chicago. So this is a hallucination. And the reason why models hallucinate is because they're trained on sequences of words. And this is fine if you're expecting something like the chicken walked across probably it's the road. But also, you have to remember that LLMs are trained on a lot of other possibly garbage stuff, like think about all the weird stuff in Reddit. So you can get unusual responses from LLMs. And then just a reminder that the vectors that we're talking about in our vector database, they come from these deep learning models that are trained on these on language tokens to predict next language tokens. So they usually come from the next to last hidden layer of the deep learning models. And especially they come from transformers. So different types of transformers. People have figured out that you can just skip the whole original transformer architecture and go with just the first part, the encoder. And those have turned into now the embedding models. And the decoders have turned into the GPT models. And so you take using these weights, it maps your inputs to an output, and the output is a set of weights in a multidimensional space. You can think of these weights now in this vector space having meaning, so that things that have semantically similar concepts are closer together in this vector space. And the vector space here is 2-dimensional, but typically there are like 1025 dimensions or more. And then this is the overview of RAG. So you bring in your data, it goes into the embedding model. The embedding model converts the inputs into weights, which is just vectors of numbers, which are stored in a vector database. And then now you can ask a question, which also gets embedded using that same embedding model. And then you search for the closest nearest neighbors in vector space to your question, which is tokenized now. And then you take the nearest vector, you stuff that as the context along with your question into the LLM prompt, and then you get a more reliable answer. So I thought I was doing something different. Oh yeah, so I'm going to talk, this is a really, really big topic, and I'm just going to I'm just going to mention a few things. So general in high level, and I took this slide from the company Truera, where they have a really nice view of the RAG triangle of evaluation. So you imagine you have a query and you do a retrieval. That's the first right side of that triangle. So the first evaluation you might want to do is the context that was retrieved relevant to this query? Then the next thing is you're going to stuff that context into a response, and you're going to get an answer from the LLM. So is the answer you get grounded in terms of, is it faithful to the context that it was given? And then the final thing is, let's measure the answer to the query. So is this answer relevant? Does it answer the question? So those are the three general approaches to RAG evaluation. And then there's this package that has become popular lately called Ragus. And I don't know, maybe you can tell me if I'm pronouncing it. You can tell me a better way to pronounce it. Ragus? I'm not sure. So they've taken that RAG triangle and broken it down into more details. So now they, in terms of the retrieval, there's context recall and context precision. In terms of the generation, now there's faithfulness for groundedness, answer relevancy. And this is all comes in a very nice package, which I'll try to demo in just a few minutes. And I forgot to time myself. Let me just turn on my timer. So another very well-known RAG evaluation method is using LLM as a judge. So this is more of like a qualitative way where you tell the LLM, you're a judge and you're going to judge the quality of these two things. Like here's one text, here's another text. How similar are they? So this is called few shot prompting for LLM as a judge, where you give it a rubric for scores, and then you give it examples. Okay, give it a 0 if, and give it some examples of what 0 type answers would be. And so this is one of the latest in this series of papers from Archive and I think this one's funny because it has a little thing where it says that GPT-4 favors itself as LLM as a judge with a 10% higher win rate, which is, it means that GPT has a little ego there, ranking itself higher when it's the judge. So I'm gonna, now I'm going to, and pushed this code just a little bit ago. So I'll send out the links later, but all the code is going to be here in our GitHub for Milvus under Bootcamp. And you'll find this under Bootcamp OpenAI Assistants. So this is just a little, I might need to make that bigger. I think that looks better. Okay, make this bigger. All right, so I've got this, basically what I'm doing is I've got some evaluations that I just played around with creating a LLM as a judge prompt. So you can see, I'll just show you some of the dirty stuff underneath, I guess. Template. Okay, so for example, you'll say things like, for the following questions, tell me the correctness, and then I wanted to output JSON, of course. And then I should probably print out this few shot prompt. So it's a very long prompt. Oops. Oops. Did I not? Oh, I'm at cell 1. Okay, so I have to run everything. Okay, so I'll just step through this. This is a RAG notebook from scratch. So what we're doing is we're going to import some libraries. We're going to okay, read some ground truths. And so this is how you evaluate a lot of times is you have like a few samples that you think are true. So in this case, I have a question, and this is all about Milvus docs. And then I'm going to have what I think should be the actual answer. And then I'm going to get an OpenAI RAG answer from OpenAI. And then I'm going to get a custom RAG answer from this code I'm going to show you. And then I'll also get the context so I can evaluate internally it for my system. And yeah, and I just for fun, I played around with another score where it was binary if the correct source was being retrieved by the for the ground truth source. So while that's running, I think I should also go to let me go to here and show you what this looks like. Oops, let me go back here. Sorry. Yeah, I think one of the first things to do is you go to OpenAI pricing and you take a look before you do anything. And this is what I did is I took a look at the pricing, and you can look at the assistants, and you'll notice that it's going to cost you 3 cents a session, and then 20 cents per gigabyte. And then this is the part that got me was each assistant has a cost for storing files. And this is I think this is going to be the expensive part. And so what I did is I played around with here. I called, this guy and then, oops, I lost my few shot prompt. And then you can tell it something like, you can tell it like, answer questions only using the context, choose a cheap model for now. And then here's where you can add functions, and you can also add files. And I'm not going to do it right now because I did it here, and I'll just show what it looks like. So I added just five documentation.txt files to it. And then I ran it for only half an hour. And it cost me 24 cents. So that was just like to get an idea of what OpenAI RAG would be like if I ran it. And I only kept it open for a little while. And I think what you can tell here is that you upload these files, and it's great that they give you all kinds of APIs where you can call it, but you're going to incur cost, especially because you've got your files in storage. So the whole time you're keeping them there, fine, you can do API calls to it, but you're paying the whole time for storage. So I myself just took my files down because I don't want to keep them up there 24/7. And I'm going to play around more with my custom RAG cycle. So that was just to give people an idea what it's like, though. But yeah, so you just go here to the playground, and you can just upload files, and then you can actually here in the chat console, I just had 4 sample questions. So I just did 4 sample questions to get my eval responses so that I have enough for a quick eval, just to see if my proof of concept works. But then of course you could use an API instead. All right, so now I'm going to go back to my code, which is here. All right, so that's what I did to get this this column here, the OpenAI RAG answer. So I populated that column. Then I'm going to run my own RAG workflow here, where I take, and this is just I think I've demoed this before, but where you just take, I'll just use a Zilliz free tier cluster, for example, and I'm going to connect to it. Then I'm going to load an open source embedding model. In this case, I'm uploading this one. And I think I've mentioned before, my technique is I always look at the benchmarks to see who's leading. So let me just do that in case people haven't seen me give this demo before. Can't escape. I go here to MTEB benchmark. And then, oops, leaderboard, oops. Leaderboard. And what you can do here is you can sort by retrieval. So I'll take this retrieval column and make sure I sort it descending. And then you look here for the smallest, highest ranking models. And so right now, I have to make that bigger for myself. Wow, these change all the time. Did I do that right? Yeah, retrieval. Okay, so this changes all the time. Although this is a pretty big model. This is 14 gigs. So I would say like the highest ranking small model is this one, which is 1, 2, 3, 4 down. This UAE at 1.34 gigs. So that would be the model I'd play around with. And so that's what I did here is I chose that model. And this is one thing that Milvus does is as a philosophy, we keep ourselves disjoint from the choice of embedding model. You can choose whatever embedding model you want. And that's because these leaderboards and models are just changing all the time in terms of the one you should pick. And so I switched to this one, that UAE model. And then I can see that indeed its dimensions are 1024. So I'm going to go ahead and use that model as my encoder. So what I do is I create a Milvus collection. I'm going to call it Wikipedia in this case. And I'm going to go ahead and just declare it. So I've done a lot more than I need to. I've declared an HNSW index with cosine distance metric here. And then successfully dropped and created it. And then I'm going to just use LangChain for the documents, document loaders from Wikipedia. So I take that and load a Wikipedia page. This talk is not about chunking and splitting, but chunking is an important decision you need to make. I'm just going to do something simple called recursive text splitting, where you have an overlap of 10%, which is generally considered the rule of thumb best practice. So I just run through and fetch the documents, 681 documents from that Wikipedia page, chunked and embedded it. Okay, so now what we'll do, I don't want to get too bogged down in this because this is just vanilla RAG that I'm doing here. I went ahead and I'm just reading this eval data set again, the ground truth, OpenAI RAG. This is the Ragus stuff. So let me make that bigger. So this is the Ragus where you just, it uses as a default, it uses a Hugging Face data set. So you just need to convert your data into a Hugging Face data set. So it needs questions, the context that got retrieved, the answers from your chatbot system, and then the ground truth answers. And then you can evaluate, and it's pretty simple. You just can define what things I want. In this case, I only chose answer, relevancy, and faithfulness because the context I can only view for my custom, not for the OpenAI RAG. And then I defined a loop, and this is what was different for me. And this is where if I went about it again, I would probably use a tool like Langsmith, I've heard, would probably be better for this. But so I'm gonna go ahead and define my my GPT model, which is GPT 3.5 turbo, define my temperature as 0.1, which is low. Use my token, define define a little function so I can retrieve from Milvus, define the overall Wikipedia search, and define how I'm going to get stuff from OpenAI responses. And then, okay, this is where things changed. So this is my custom execution loop, where in general, I'm going to do a moderation step using OpenAI API call. Then I'm going to retrieve the closest chunk using a default collection. You can imagine like this is like your default internal document store. I'm going to check if the score is too low. I'm going to go ahead and check the intent of that user's conversation. And based on the intent, I might have some logic to check a different collection that might have different data. So in this case, I've got one collection that has Milvus documentation, read the docs stuff, and I've got another collection that has Wikipedia docs in it. So I'm going to, like, based on the user's question, I'm going to either search internal docs or I'm going to search the Wikipedia docs. But you could imagine you might have different sets of docs. And then I'm going to generate the answer. I skipped this moderation. I changed moderation to evaluation. Okay, so yeah, so that's what this looks like. You can check out my GitHub, I guess, to look at this function, probably more detail closer later. But let me just run it for now. So I'm going to pick a question. And when I run this, you'll see that, oops, I forgot to uncomment. No, I guess that's all fine. Okay. So you can see that it did a retrieval of Milvus docs. It found a chunk. It calculates a distance score of 0.62. It says that that 0.62 is high enough. So then it's going to proceed and ask GPT for an answer, stuffing that context into the prompt. Then I'm going to do an evaluation using Ragus, and I calculate faithfulness and answer relevancy. Based on, and this here where you might have some threshold deciding if that metric is high enough, then if it passes your evaluation, then you return it to the user. So the answer says that this default metric is L2. And I could change it to another one. Like, let's say I happen to know that 3 is the New York City question. So I'll just change it to ask about New York City. And now it's going to go to Milvus docs, and it's going to get a very low score because Milvus docs doesn't say anything about New York City. So it's going to say that it's too low. I'm going to check for the intent. It looks like you're asking about New York City. So now I'm going to go fetch from second collection Wikipedia. So now it's fetching from Wikipedia. Calculates another, see the distance score is much higher now. Cosine is reversed, so higher distance score means it's a better result. So, okay, it's above my threshold. Ask GPT 3.5 to answer this question. Calculate the evaluation. If the evaluation scores are above a certain score, then you return this answer to the user. So this is just like this is like a really simplistic example, but this is kind of like what custom OpenAI assistants can look like. It's basically just partly having an LLM make some logic choices for you, and partly some user flow logic that you kind of mixed in the two. So yeah, and then down here, I go ahead and I just run Ragus for everything. So here I just ran it for all of the OpenAI RAG answers. What I found for OpenAI RAG is I found faithfulness pretty much 0. And that makes sense because I had 0 context. So how could it be faithful to the context if I don't have any context? Yeah. And my custom RAG, I have more reasonable numbers. So I think I need to do some error. I probably need to do something error control on myself, that if there's no context, I shouldn't be calculating context numbers. So yeah, I guess that's just kind of it. And that's how I played around with OpenAI assistants versus OpenAI canned RAG. And this is how I evaluated. So yeah, let me know if you have any questions. Thanks.
You said it cost 24 cents. Was that for 6 documents or the time it took?
So it's a combination of time. It's gigabytes per hour, and yeah, it's gigabytes per hour of storage plus all of the calls that you make to the assistant. And I had 5 little documents.
Hi, thank you for the demo. Is the Ragus library the main reason you were using Python? Theoretically, I'm wondering, could you just do this in JavaScript? It seems mostly API orchestration.
Just because I'm comfortable with Python, yeah. But most of these libraries have Node SDKs as well. But I'm not a Node programmer.
Could you add custom metrics?
Yes, and that's what I played around with. I played around with a binary metric that was 0, 1 if the retrieval source matched the URL of what I knew was the truth source. And I played around with the LLM as a judge score as well.
Awesome.
So some of the reason I think you would use the OpenAI Assistants tools because it does a little bit more than just the vector search on retrieval.
Yeah.
So just on the Milvus side or the I forget the parent company name. Do you guys do kind of like a hybrid search for retrieval, or is it just the like cosine distance search?
What do you mean by hybrid search?
I think hybrid search, like some of the like OpenAI and stuff will do like combination full text search, keyword search, and vector search, and then take like the highest matching.
Okay, so we can do filtering at this moment. So it's kind of like some people say, oh, do I need to combine my vector data with other data and combine it with a SQL database so I can do like where such and such, or limiting my query. We can do that, but we don't have the full hybrid search at the moment, but it's coming soon.
What are the reasons to do custom RAG instead of OpenAI RAG?
So yeah, I think that was just the point of my experimentation, and I didn't do a great demo. I think it's you can look at my full code on the GitHub, but yeah, it was just to kind of play around with this LM as a judge idea, custom metrics, and just be able to have more. I think it's really so that you can have more insight into the retrieval itself, which is really important in this case for the chat. So they can get all those Ragus metrics, which you can't really get with OpenAI. And I think that's just for, as a developer, for satisfaction, you just get more insight and then you know what to tweak. And then also because it's open source, you're not paying as much as you probably would pay otherwise for that whole development cycle. Okay, thanks. So I'm doing a little double duty here. So I'm gonna, our next speaker is George Williams. He's a generative AI researcher and Edge ML startup advisor. He's worked at the intersection of software and hardware industry and research, systems, and machine learning. His past roles include being an individual contributor, a researcher, a team leader, a chief, a director, and he likes to build things, communicating ideas, and being a bridge between customers, sales and marketing, product engineering, data science, and AI. So welcome, George.
Testing. Can you hear me? Oh, fantastic. All right, who wants to hear about benchmarks? Yay. Or you can go outside in the rain. I recommend you listen to some wise words about benchmarks. All right, I've done this presentation in the past, and I like to ask, who are the algorithm developers out there? Show of hands. All right, cool. Who's heard of Pareto front as a concept? Good. And Pareto front is the typical trade-off we think of in approximate nearest neighbor, where you're balancing some metric of accuracy like recall versus some performance metric like latency or throughput. So good, I can work with this audience. This is good. The title of my talk is, are CPUs enough for vector search and approximate nearest neighbor? And I'm George Williams. And thank you for the great introduction, Christine. So I'm going to focus most of my talk on this NeurIPS Big ANN challenge from 2021 that we created. And what we did was we invited algorithm developers to compete on a broad set of vector search, dense vector data sets. And we measured the performance and ranked the submissions on different hardware configurations. And so I'll be talking a lot about hardware in this talk. I'll talk about that competition, the competition we just finished in 2023, and I'll talk about the future of these competitions and how you can get involved. Is that better? Okay, thank you. And if there's time, I will get into this, this new golden age of hardware that we're all seeing right now. All right, so who was involved in this competition? There you can see folks who were organizers of the competition. They came from various places. You can see participation from the hyperscalers, Microsoft, Meta, Yandex, and Baidu. And we had academic participation as well from CMU and the University of Copenhagen. And GSI Technology right there. I was at the company at that time. It was a small fabless semiconductor company. So a good cross-section of industry and research. And I think it reflected what we needed to do at the time in 2021 with vector search and measuring vector search. We needed participation from people that deployed this at scale and also from researchers who wanted to push the state of the art. So what was our motivation in 2021 for doing this? Well, in 2021, there was actually a great site out there, ANN Benchmarks, created by Eric Bernhardsen and Martin Aumuller. I think some of you probably know this open source site. And they actually did a fantastic job of fairly evaluating a lot of the, or most of the openly available open source algorithms for vector search that were available. And I think they also did a great job of democratizing that Pareto front trade-off I talked about, right? The trade-off between recall and a performance metric like latency or throughput. One of the things that you'll see that they did, and this is a set of data sets that they benchmarked the various algorithms on. You can see it's a pretty good set of data sets in which to compare all of these algorithms. You can see lots of distance metrics there, and a good set of dimensions. One of the things that the hyperscalers, especially Microsoft, noticed is that they were seeing the need to scale these data sets beyond just 10 million. So the largest data set you see there is 10 million out of Deep 1B. So thus was born this challenge. Plus, we wanted to also give researchers the opportunity to push the state of the art on things other than just CPUs. So that was our mission, to create an open competition to measure algorithms on large-scale data sets, 1 billion records for each of the data sets. We wanted to have researchers, like I said, push the state of the art in what they can do with different hardware configurations and different kinds of hardware. And as a bonus, one of the creators of ANNbenchmarks.com became an organizer. And this is great because what we were trying to do, I think, complemented what ANNbenchmarks.com was doing at the time. So a little bit about the competition data sets. I think you're probably familiar with these two, Big ANN and Deep 1B. They've been staples in the academic community for at least a decade. We added four new data sets. And these were contributed by the hyperscalers who helped organize the competition, Meta, Microsoft, and Yandex. And I think that was really good because a lot of the work before 2020, 2019, 2020, a lot of the work around pushing the state-of-the-art in vector search was being done in academia. And now the hyperscalers and industry was starting to take up a lot of this work around benchmarking and evaluating. In detail, this is what the data sets look like. Some additional attributes of these data sets. You can see there that 5 out of 6 of them were the typical KNN kind of query type. So getting the nearest neighbors within a range, a neighborhood range like K. We use 10 for our competition. You see also there are different distance functions. For these data sets, we used Euclidean L2 distance, and you'll see one of the data sets had inner product. And one thing I should say about the range search data set contributed by Meta, range search is when you provide a threshold and you're just trying to get all the neighbors within that threshold instead of a top K. But a good set of data sets for a competition that range from ints to high precision floats. All right, competition tracks. We featured 3 tracks in this competition. And I'll summarize those here very briefly. So track 1, we evaluated all of the submissions using a data center server grade machine with 64 gigabytes of RAM. The second track added an additional high throughput solid state disk, 2 terabytes. And the third track actually had no hardware limits at all. People could submit their own hardware as long as it was commercially available, and they showed an evidence of cost. And we also added the requirement that we had to have the ability to monitor the power of that hardware. I'll talk a little bit more about the hardware in a second. So again, first 2 tracks had a limited hardware resource budget. We ranked participants by recall at 10 specifically. And again, track 3, no hardware limits other than it was commercially available. We actually ranked participants by 4 different metrics: recall, throughput, queries per second, a measure of power of the algorithm, and then the overall cost of deploying the solution. All right, a little bit more about the evaluation hardware. So the creator of the competition was from Microsoft, which is actually not the reason why we chose Microsoft Azure machines in which to evaluate the submissions. Actually, Microsoft gave us a pretty healthy donation in which to, they gave us a lot of credits in Microsoft Azure. So that's the specific system that we use to evaluate the submissions. And you can see there, it's about 32 cores of processing power, 64 gigabytes of RAM, like I said, and modest file storage, 256 gigabytes. We also employed another machine for participants that needed help building an index. If you've ever built an index for a billion scale data set, you know it takes a lot of processing power and time. And so for those who needed it, we gave them this beefier machine with more processing power and a lot more memory. It turns out we didn't rank participants on their ability to build an index within 4 days. We didn't use that in the ranking. Something we considered and something we might consider in the future. But the top one, that was the evaluation hardware that we used. For track 2, what we did was we used this machine from Microsoft's optimized, storage optimized series of machines, fewer cores, but a healthy amount of solid state disk, so 2 terabytes of NVMe disk. So just briefly, once again, 32 versus 8 cores of processing power between track 1 and track 2, 64 gigabytes of memory, but track 2 added an additional 2 terabyte of solid state disk. And if this is 2021, the prices haven't changed a whole lot. But if price is any indication of performance, you can see that you're paying more for processing power in the cloud than you are for extra storage, even high throughput storage. Okay, track 3. Yeah, this is the wild, wild west track. And again, people could submit their own hardware as long as it was commercially available. Power monitoring was super important here. Access, they either could send the hardware to an organizer or they gave us SSH access. And that proved to be pretty important for a lot of the corporate participants in this competition. So we needed to log into the machine, make sure it was legit, run the algorithm, in some cases looked at sensitive parts of the source code that they couldn't release. But there in general was no issue with access. Other than that, there were no limits to this track. All right, let's get into competition ranking. So as I mentioned, we primarily ranked algorithms and submissions on recall, right? The Pareto front tells us that there's this relationship between recall and throughput. And so we actually track throughput too. Recall at 10 was the metric that we chose. And the query set was a set of 10,000 query vectors. For throughput, we did batch, which means that we essentially sent the algorithm 10,000 queries and measured how long it took. So we used a batch throughput measure. And we also gave participants the ability to choose 10 different configuration parameters for their algorithm. And I think if any of you have deployed any kind of vector search algorithm, you can parameterize it in specific ways to get just the kind of performance that you want. And so people could submit their algorithm with 10 different configuration parameters. And so with those parameters, you can get a sense of what that curve is going to look like. So, one question that comes up is, right, you're going to have recall across a curve, right? Which one do you choose? And we decided to implement an operational threshold at throughput. So people had to meet that threshold at least, and we chose the highest recall above that threshold. So where did we get the operational thresholds? For track 1, track 2, and track 3, these were the throughput operational thresholds that we used. 10,000 queries per second for track 1, 1,500 for track 2, and 2,000 for track 3. And if you're asking where we got those were measured from baseline algorithms that were contributed by the organizers. So just to geek out a little bit on algorithms, the first track, Meta donated their face IVF PQ, so their clustered product quantization algorithm. I'm guessing that a lot of you have played with FACE, that library, and you've probably used this. It's kind of their intro ANN algorithm. Track 2, the baseline algorithm was supplied by Microsoft, their disk ANN algorithm, which is also an open source algorithm. Some of you I know have heard of it or even used it. Phase 3 was the same algorithm from Meta, but running on one V100 NVIDIA GPU. All right, so those are the baseline algorithms. Let's go quickly to the results. All right, so these are the winners for the recall benchmark for the various tracks. So track 1, Kaohsiung, collaboration of Kaohsiung and Tsinghua University. Track 2 was a collaboration between Zilliz and Shanxi University of Science and Technology, I think, and Intel using their Optane non-volatile memory technology won track 3. The devil's in the details here, how we actually rank and chose a winner What I'll just show here is the performance of the track winners on each of the data sets. So here you see the recall for 4 out of the 6 data sets that the winner was able to actually qualify for. It actually turned out to be, it's really hard to work on to develop an algorithm for 6 billion scale data sets as it turned out. But a lot of people did the best they could. 4 out of 6 was actually pretty good. And you can see modest recall here between 70 and 80%. This is the winning submission. We originally had 15 participants for this track. And if we look at the baseline, provided Meta's baseline, you can see that 3 out of 4 data sets Meta was able to, or this team was able to beat Meta's baseline algorithm. So they did a great job. Track 2, this was a very challenging track, and we had originally 5 different participants. And if we compare the track 2 numbers with the baseline actually does pretty darn well in this track. But this collaboration, they were able to beat one of the KNN data sets, and they beat the baseline handily in the range search data set, which is that very last one there. So really hard to win in this track, and that collaboration did really well. So now we go on to track 3, and you can see sort of night and day between track 1, track 2, and track 3 here. Intel was able to get 99% recall on all the data sets that they qualified for. In many ways, we shouldn't be surprised, right? If you constrict a billion scale evaluation to 64 gigabytes of RAM, whether you have additional disk or not, it's going to be challenging. And in this track, you can throw as much hardware as you want, right, to win this benchmark. And so it's pretty impressive. At the same time, we're probably not, too surprised we're getting such high recall. So if we look at actually how it did on the compared to the baseline, it beat the baseline handily in all the data sets. All right, so I talked about the primary benchmark recall for all the 3 competitions. We added 3 more benchmarks for track 3, throughput, power, and cost. And those were the winners there. You can see that Intel, with their technology, got 3 out of 4 of the 3 out of 4 of the benchmarks, and NVIDIA on an 8 GPU system won the other track 3 benchmark. So I'd like to go over some highlights here really quick. The track 2 winner was a really clever algorithm based on hybrid clustering. And they did a great job actually of optimizing the memory layout between RAM and SSD, and that turned out to be really the trick to winning in this track, leveraging how much RAM you used versus how much of the SSD you used. The baseline actually is probably the king in terms of balancing RAM and SSD, and so the way this algorithm primarily works, it compresses vectors, it has a graph structure that it keeps in RAM, but it also keeps the high precision vectors in SSD. And so it balances really well the communication it has to actually maintain between both kinds of memories. It's an open source algorithm. If you're interested, take a look. It's really good. So the Intel and Optane is really interesting. So what you see there is their hardware, and it's essentially solid state technology. Their solid state technology, but it's in the form factor of memory that fits in the slots that are in RAM on a motherboard. It's a graph-based algorithm, a lot like DiskANN. And you can see here, this is first and second place. Intel barely beats out NVIDIA in this particular benchmark in recall. I mean, they were neck and neck till the end. You can see the difference between the various data sets. They're just by 2 or 3 decimal places. The throughput winner was NVIDIA, and it was based on a submission of A100 GPUs, named 8 of them, in a DGX system. So they're tightly interconnected GPUs. Their algorithm is pretty straightforward. It was a lot like IVF-PQ, except they distributed clusters across all of the GPUs. Here, they're the clear winner, and that says 747,000 on big ANN, 1,000 queries per second. So they did win this benchmark hands down. Power, that's become very important for a lot of state-of-the-art algorithms. You know, AI, we think of GPUs being power hungry, but we also want to make sure that, you know, we're power efficient when we're talking about vector search as well. So our metric for power was measuring power per query, and we leveraged the IPMI standard that data centers use in order to monitor the power of hardware. And you can see here that Intel, lower is better. Intel won by a factor or even an order of magnitude in this competition. NVIDIA was a second. Cost consumes a few things. It's what's called CapEx and OpEx. Data centers are not just concerned about how much hardware costs to purchase, but also how much it costs to maintain that over a certain period of time. So we used a modified formula that data centers use, in which you measure the power or the cost of maintenance on an application. In this case, the application was maintaining a vector search algorithm that could perform 100,000 queries per second, which is kind of web scale number that Google uses, over the course of 4 years, which is the lifetime of a lot of hardware these days.
4 minutes.
Thank you. And we use 10 cents per hour per kilowatt. So you can see here, Intel did a fantastic job in terms of power as well. All right, so that was 2021. 2023, we just finished. We decided not to do large scale, billion scale data sets, and we decided not to do hardware in this competition for a lot of reasons. But we actually did make it pretty interesting. If you're interested in the 2023 NeurIPS sponsored competition, go to this link here. What did we do? We actually created 4 tracks, and we evaluated on standard server hardware on smaller data sets. You can see at most it was 10 million records. But the tracks reflected a lot of challenges that people have integrating vector search in real applications. So filtered is the combination of dense search and tags, meta information. Out of distribution, very challenging track where the distribution of your query vectors is very different than the distribution of vectors that an algorithm trained on. We had a sparse track as well, and a streaming track to reflect the fact that a lot of these databases, right, are not just read-only. You have to update vectors, you have to delete vectors, right? They're real databases. So check out those results here if you're interested. What's next for competitions? We're actually going to bring back large scale and the novel hardware track for the next competition. We're going to have a RAG use case, and we're going to measure participants on that. People have been talking about other benchmarks like index build time, query by query latency, larger and continuous evaluation like MLPerf. And if you have other ideas, right, this is an open competition, please go to that site there or reach out to either all the organizers or myself, because we're just starting to plan for the next competition. And so do I have time?
You should wrap up.
I should wrap up. So maybe they'll invite me again to talk about my opinions on the new golden age of hardware, but I can take a couple questions if you have it.
Thanks. Let's thank our speaker.
Where do you think the trend is going to be in 10 years from now?
For benchmarking?
Yeah.
Yeah, I come from hardware, and so I think the novelty of hardware is going to push what we can do for the performance of these algorithms. I think we're going to get into an area where we can scale on raw vectors, and we don't need to create indexes. You're asking me 10 years from now. We might not be talking about approximate, right? We might be talking about brute force looking at all the vectors, and we can do that in a small period of time. I think that's where the memory market is headed right now. Yeah.
Thank you for presenting. One quick question about the golden age of hardware. Do you see that specialized hardware is going to be the norm when it comes to building out, AI apps, or do you see that commoditized hardware is going to really kick off and our MacBooks or laptops are just going to have this hardware built in?
I think so. And this gives me a chance of actually doing my last slide, right? So the challenge of building chips today is, and I've done this, I've done a couple of efforts building chips. A new chip costs about $100 million to make, give or take. A lot of them are more now. And it takes like a year and a half, right? Just to get the first generation of a chip out there. And that first generation, right, we're going to need more generations after that to actually get into the market. That does not include the software compiler ecosystem that needs to be developed in a lot of cases, which takes not only money, but time. And there used to be an adage many years ago with IBM, no one got fired for buying IBM. And that sort of captures the notion that, why stick your head out for new hardware when you have hardware that works, is reliable. You don't have to tweak your software stack, it just works. And so swap NVIDIA for IBM, and now the adage is becoming, no one got fired for buying NVIDIA. And there's a lot of competition out there. So what I'm excited about is this new thing called the chiplet marketplace. Maybe you've heard of chiplets, but the idea is that we're going to take the best of what a semiconductor company is making. We might license their intellectual property, or we might actually take part of their chip that we like. And we start to design modularly and source from different companies in a Lego block style of building new chips. And so there's emerging protocols and effort to make this possible. It's something that software has been doing for years, right? Modular kind of architecture. And we're starting to see that uptick within the semiconductor community. And a lot of people are really excited about this. What's exciting to me is that you get to reuse software, right, for existing chips. What a lot of people think is that a lot of folks like you and me, right, who don't necessarily live in the chip world all the time, will be able to design our own chips that are 10 times faster and 10 times cheaper. And so I think for a lot of companies that want to get into microprocessors and chips, this is going to be how they're going to get into it. That's the innovation that I'm seeing starting to happen, that a lot of companies will be able to start to take advantage of in the next few years to build their own chips. Yeah.
One last question over there.
I have thanks a lot for sharing the results. I was curious about, you mentioned the winners of the different tracks, like track 1, track 2, track 3.
Sure.
I was curious, what's the difference between the winners and the people who came in second and third? Was there a substantial difference, or were they bunched up together?
Oh, you know what? If you go to the actual website I published here, we actually list all of the performance of all the competitors in the track. If you want to, I just wanted to summarize it here because if I show the whole thing with the numbers, it gets too overwhelming for a slide. But it's on the website for this competition. But yeah, good question. Thanks.
All right. Well, I'm sure we have more questions, but thanks so much, George. And George will be around afterwards if you have more questions. Thank you. Okay, so our next speaker is Alexy Khrabrov. He's open source science director at IBM. He's the founding chair of the Generative AI Commons at the LinuxFoundation, head of AI community for the AI Alliance. He holds a PhD in computer science from the University of Pennsylvania, the founder and organizer of Bay.area.ai, the most established AI meetup, Scale by the Bay, the 10-year-old community conference for software engineering, data pipelines, and AI at scale. And he's the founder of Open Source Science, the program of NUM Focus and IBM Accelerating Scientific Discovery with OSS. So welcome, Alexy.
Thank you, Christy. Let me set this up here. Let's see how this works. Okay, let me make sure it's not making noises. All right, excellent. So I know this is the last talk of the day, and you guys been here for a long time. Also, I want to really thank Christy for setting this up. This is great, and Christy is a great organizer. And GitHub, for the first time I'm here. I've been a whole bunch of startups, and some I've been around this place. Really grateful for the hosts. Who works for GitHub here? Who are the GitHubbers? See a lot of people. Nobody. People just faking it in hoodies. I got it. They're sneaking in. Great job. So yeah, and I mean, this is amazing, right? So we are at the place where like most of our code, like who uses GitHub for the startups? Everybody, right? Who is not using GitHub? Is there any person who is not using GitHub? Great, right? So we're at the birthplace of all this stuff, which is amazing. So I wear a lot of hats, and I'm going to talk about the new thing, which is coming up in the community space. So I'm a lifelong community organizer. I'm a technical person. I've been a developer, and so I lead the initiative called Open Source Science at IBM Research, which is a community initiative hosted at NumFocus. Who heard about NumFocus? Who heard about Jupyter, NumPy, SciPy, right? All these projects belong to NumFocus. NumFocus is small, no one knows about it, but it's a home of the Python data stack, everything except for PyTorch. PyTorch now belongs to LinuxFoundation. There's a PyTorch Foundation, and I've been elected the chair of the new generative AI Commons, which is basically a place where we talk about open source AI, which was established in September last year, against getting up to speed. So if your company is a member of the Linux Foundation, or you have friends at Linux Foundation, you can join our commons. But I'm going to talk about the AI Alliance, which is a new consortium which was announced on December 5th. And I think it's going to be a major force in open source AI. So before I go there, I just want to mention a couple more things. I am also Meetup organizer of Bay Area AI, which is a URL, which is the oldest, the most established AI meetup still working in the Bay Area. We have about 5,000 members, and we are back live. So we're gonna gather again at IBM on 4025 Market, January 31st. We're gonna have a talk on VLLM from Berkeley, which is an open source project, and Berkeley is a member of the Alliance, and IBM is the founding member of the Alliance, and also around this conference of Scale by the Bay, which runs every November for 10 years and is basically a conference of the meetups. And so we'll welcome everybody to speak there. It's also about open source software engineering, data pipelines, and machine learning and AI. So let's see how this works. So for some reason, it's not advancing. So okay, I use this. So prologue, right? We're in the crucial moment in the time of AI, and everybody is doing the same thing. So I wonder, how do you guys get your knowledge about AI? Do you read blogs every day until you're blue in the face and scroll and read papers? Do you talk to colleagues? Let's say who mostly get the information by reading things? Okay, and who gets the information by coming to events like this and listen to speakers? Which one is better? Which one do you prefer? Who prefers in-person communication? And who prefers to sit in a corner and read a bunch of stuff? Right, a few people, this is fine, right? So what I'm hinting at is there are different ways to handle uncertainty. And honestly, who knows for sure how to implement AI for the enterprise? Who actually knows how to do it? 100%. Has anybody done this? Right? So if you look back at 1 year of generative AI, there is a lot of aspiration. There is not a single talk at any conference where somebody definitively demonstrated how they replaced any human function with AI. So nobody replaced the customer service department in a Midwestern bank with AI. Nobody replaced all the writers or copy editors with AI. All right, we're very aspirational, right? On the one hand, we have AI doomerism, and we think it's going to take our jobs and kill us. On the other hand, nobody really replaced like a Zendesk help desk with AI, right? And even OpenAI, if you chat to the chatbot of OpenAI, it was demonstrated it's not powered by ChatGPT. It's a really like old school JavaScript chatbot hooked up to something else. So people do not yet trust AI, and the reason is we don't know what's going to happen, right? So if you're a startup, there's a whole bunch of startups here. You come to a bank and you say, I will replace your customer service department with ChatGPT. I need a couple things. I need to have all of your financial data of your customers. So give me your Oracle financial database, give me all the 3 keys, and I need to read all your financial transactions, right? Because customers are gonna say, why did this thing charge me? So I need all your financial data. And also I need all your CRM data. I need all of your customer data, right? Because I will need to look it up. Obviously, you're not gonna get this data, right? Because until an enterprise is 100% sure this data is not gonna leak, they're not gonna give it to you. And so far, we do not believe we know, right? If you train a large language model and you do fine tuning and you feed it into your RAG, where is this stuff gonna end up, right? Like for the first time, we have really kind of bad feeling about this because there is no assurance. We have control, right? For the first time, I would say in software engineering. So what we also see, we see the rise of anti-open source sentiment, right? Which is really something new. So for those of us who've seen the beginning of open source revolution, I've seen Richard Stallman come into Soviet Union with like a backpack full of GNU tapes. He wanted to bury them in Siberian permafrost in case of the Third World War, so open source persists, right? Like we've seen this, take over the world and become an obvious direction, right? So everybody here who puts their stuff on GitHub generally believes that open source is the way. However, now we have the dark forces of reaction, right, rising their ugly heads and saying, no, like we should close it up. It's dangerous. So, and we have logical arguments from a lot of people who basically argue against openness. And also they take action at the government level, right? So we see basically legal capture of open source by these forces who basically promote legislation that we should close it up, we should shut it down, we should regulate it, we should ration it, we should inspect it, and so forth, right? So for the first time in software, we have, in the recent 40 years, we have a lot of forces aligned against open source. And obviously, there's a lot of people who are not happy with this. Also, if you look at the closed source solutions, they're tied to specific setups, specific companies and owners, right? So if you are from a global diverse audience, there is now a concept of AI sovereignty, which is becoming more urgent. So a lot of countries are saying, I'm not gonna ship my data to the US, to an unknown place where it's gonna be used for whatever purposes, even though you give me assurances, right, that you're not gonna use it for stuff. Like, if you are a big corporation in Asia, you are not really interested in doing this. Also, if you are, say, an industrial AI player like Bosch or Fujitsu, you want the AI you use to live on premise in your factory, in your power tools, right? You want control and transparency. So on the one hand, we have forces of closedness kind of uniting behind this idea of safety and using it to promote closed source AI. And on the other hand, we have a lot of users who want to innovate and a lot of companies. So the answer to this came basically in December as the AI Alliance. So the AI Alliance is a industry and government and nonprofit consortium. Basically, it unites all kind of entities. And it started in June last year with a collaboration between IBM and Meta, right? So the idea was IBM is basically the trusted provider of software and data solutions to all kinds of clients, including governments, right? So when people need really trusted solutions, they turn to IBM around the world because they know that we have secure storage, we have legal understanding of data. So if you deal with healthcare, government, and so forth, this is the place you turn to, right? So, you know, if a startup comes to this Midwestern bank and asks for all their data, they are unlikely to get it. If IBM partners with the same bank, they're already probably a customer because they probably buy our hardware, they're probably much more likely to work with us, right? So it's a good thing. It's a good thing that you've been 100 years in business. On the other hand, IBM is actually an innovator in open source. So I wonder how many people here know some open source innovations which came out of IBM? Can you name one crucial piece without which we would not have the internet as we have it? We would not have AI as we have it right now. I mean, IBM supports a bunch of this, but one thing is crucial to all of this. Like data centers, what do we run everything? Linux, right? So Linux would not happen if IBM would not support it, right? I don't know if you guys know the history, but Linux was basically a competitor to Microsoft, right? At some point, Microsoft sued Linux users, and IBM stepped up and first of all defended Linux. It contributed crucial IP like schedulers to Linux, and it basically was one of the creators of LinuxFoundation, right? And LinuxFoundation was set up to maintain Linux kernel and pay Linux torvalds to do this, and it's basically mushroomed into this all-encompassing foundation, which is a home to many projects, including LFAI and Data, PyTorch Foundation, right? So because of Linux, we have commodity data centers. So Google was able to piece together the data centers based on a bunch of commodity PCs, which in turn led to the famous Hadoop paper, which led to big data, which led to AI, right? So I think we can trace it directly to open source viability of Linux, but also, if you remember the early .com years where Java was king of e-commerce and Sun Microsystems and Java were one of the engines of adoption of big data, and Hadoop obviously runs on Java, and Spark followed that. Right now we're in the Python kind of age, but without that, we would not have big data as we have it. Again, IBM supported Java with a lot of resources, right? So I think Linux and Java are two things which we implemented, and AI is the next thing, right? So I think in IBM history, we looked at everything and we realized like this is the most impact we can have. If we put our resources behind open source AI, we resolve a lot of uncertainty and FUD which surrounds AI. But obviously, you know, there is a lot of leaders. So we're very fortunate that we have this relation with Meta, and Meta obviously with Llama made a huge splash, right? Meta really demonstrated that having open source models, you can compete with proprietary models. I think it really gave assurance to this whole ecosystem. Plus, Meta is the maintainer of PyTorch, which recently basically became the AI platform. So Meta spends enormous resources on PyTorch ecosystem. And at Meta, the PyTorch and Llama ecosystems are basically managed together. So that was the core impetus. You know, IBM contributes a lot of work to PyTorch. We have our own watsonx data pipelines, which can work with any number of models. We have also Hugging Face partnership, right? And so Hugging Face is the place where community gathers, convenes for open source AI. So this conversation basically led to this idea that we should really pull together our resources and set up this alliance. And as you see, it very quickly came together. We have 60 members from around the world. The website is thealliance.ai, and it's very early, right? We have a very basic kind of information and a contact form. You can, if your company wants to join the alliance, you can basically, fill out this form. And we have the first set of members on the website. We have a second set of members waiting kind of announcement, and I'm really happy to say that Zilliz is one of them, right? So we welcome leading open source solutions into the alliance, but we're not dogmatic. So we have members who have closed technology. So we do this right now ourselves, we're not in any foundation because we do not, want to stymie innovation. We don't want to tell you have to sign like purity pledge. We will move you towards open, right? But if you come with open, like closed source things, we'll work with you. But also we have companies like Intel and AMD, which work on software, hardware co-development in the space of AI acceleration, right? So I think we also all need to think, right? Like now we have this dichotomy of GPU poor, GPU rich. People are actively working on open hardware, and they're working on open hardware accelerators for AI, including training and inference. So we have a set of companies in the Alliance which do that. And obviously we'll cross-pollinate the expertise of software engineers and hardware. And what George said was lovely. Like, I really love to hear this because I'm not a hardware guy, but I am very excited about this convergence. So that idea that you can use software and make your own chips, I think it's exciting. So right, so this has been received with tremendous enthusiasm. We've got enormous coverage. Our second batch includes some big names. You will see that soon. Right. So what do we do? Right. Essentially, this is in the lines of builders. So we do not want to preside over AI and have slick kind of politicians going to Washington. You have to do that, but this should not be the focus. Right. You have to build. And you have to actually build quickly. And we really need to basically pull together all the open source projects for all members. And we need to converge them. We need to prioritize them. We need to throw our might behind the most promising projects, right? To make the models better, data pipelines better. We need to integrate with enterprise. Nobody is doing it properly yet because it's a lot of work. If you come into an enterprise, there's a million things you need to do to integrate to it securely, right? And not any single startup or even one company is capable of doing it properly, right? So we need to figure it out. How do we come to the enterprise? How do we come to the Midwestern bank? How do we come to a business? How do we convince them? Here's the way to try. So we need things like reference AI architecture. We need a reference stack, something like LAMP stack, right? A gem stack. We need an AI stack. So we need to assemble it from our members' contributions, right? We need to have ready to try solutions, which will be turnkey, and we want to be chips to apps, right? We'll need to be able to give you an idea how to use various GPU accelerators. We need to be able to tell you what kind of Kubernetes setup you need to run for different kind of, or similar, right, orchestration, what kind of data pipeline you need to have, how you integrate with Kafka, Spark, or Cassandra, and so forth. And how do you do the last mile with the developer framework. So we're very happy to say that we have both LangChain and Llama Index as our members. From the beginning, we have companies like Anyscale with Ray, right? And basically the next batch will include Databricks and Snowflake. So we have data. And I think we have leading universities, including Berkeley. So I think we're really well positioned, right, to tackle this. So specifically, what kind of project areas we have? So we're soliciting projects from each member that the member wants to promote as this example best practice, right? Which can be in different positions in this data pipeline. And we also obviously need people to populate our work streams. So we'll have 6 work streams. They're listed here. And basically, they touch on all the aspects of AI as we know it right now. So we need skills, we need education. We also focus on research. This is something which Silicon Valley often overlooks because of the very short attention time span, but IBM research exists for several decades. For instance, we developed open source geospatial model of climate with Hugging Face and NASA. We work on material science models, right, in electric batteries, carbon capture materials, and drug design for cancer drugs. So this is long-term work which we do with NSF, NIH. And there is a lot of heavy lifting, which is beyond the time span or investment of a startup ecosystem as it is known here, right? So if you go outside of Silicon Valley, there is a whole bunch of stuff such as industrial AI, geospatial, healthcare, which is very hard to do to begin with. Right, but the problems are very hard, right? Like this is not selling stuff on the internet; it's treating cancer or kind of arresting climate change. So I think this is very interesting. This is where we differentiate ourselves from a lot of commercial consortia because we have the strong research component. The research is funded by governments, right? So here we have players who are interested in long-term solutions and not commercial gain, right? Which coexists with, traditional businesses and startups. So I think it makes it a super interesting ecosystem. If you gravitate towards research, you can find a place working on this kind of problems. If you want really succeed commercially, you can work with enterprise adoption and being early, right, with this. We need tooling, right? Obviously, a lot of uncertainty comes from lack of tools. So we need to help developers be assured. We are heavily investing in hardware accelerator, which IBM has capability to do, and its partners also, right? So this is, I think, another difference. This is not a pure software consortium. We tackle the whole spectrum.
5 minutes.
And ML Commons is also a member, right? So we can benchmark. We basically need to be data-driven. We need to quantify trust, safety, reliability, and figure out how we basically benchmark it, right, and monitor it in deployment. And we're all about ecosystem, right? So, and finally, we are going to do advocating, for laws which permit open innovation. So we're not restricted as LinuxFoundation, for instance, or some nonprofits. We can do lobbying. We have government relations. Our members, are experienced in this. So we're going to push back against closedness, and we're going to promote openness, and we're going to back it up with advocacy. So timeline, right? Basically, currently we have invitation-only members, and we are actively adding to them. So the second batch will be announced in January. If you urgently believe your company should be a member, reach out to me. My contacts are all above. So alexy@ibm.com is my email. @chiefscientist is my X, Twitter, and I'm chief scientist on most social networks because I actually had been a chief scientist of a public company. So I got these nice handles. Connect to me on LinkedIn. I'm going to hang out around here. But generally speaking, right, like we will ramp up our web presence. So we'll hopefully soon put out the website where there will be all kind of ways to engage. And we'll have a kind of individual membership tier. You do not have to, your company does not have to be a member. If you work on one of these open source projects, we want to figure out how to engage everybody, right? Because basically we want network effects. I think, right, like the problem with NI is fragmented. There is it's hard to understand where you should prioritize your work. And so this is what we want to do together. We want to figure out what are the most promising directions to make sure open source AI is the way we're going to do it. So that's it. And I have time for questions.
Thank you, Alexy. Questions. Maybe the first question is, how can somebody who's sitting here contribute?
Right. So for now, right, we're in the formation stage. So you can go to the website and leave your contact information, right? Once we have, and basically write down what you want to do, right? So this is about doing. If you just want to like follow up and see announcements for which of the websites, like we will be present at multiple events. We already sponsored AI.dev, which is the Linux Foundation AI conference, which was held in December in San Jose. The next one will be in June in Paris. And the next one will be in December, somewhere in Asia, probably Hong Kong. Right? So the AI.dev will follow the cycle of open source summits. So we're present at Open Source Summit, we're present at AI.dev. So I'm going to run Bay Area AI now as the Alliance Meetup. So we will have monthly events. Next one is January 31st. And hopefully, once we have the mailing list, you can get updates and involved in work streams.
Cool. So let's say that you have categories of developer tools. It'd be arbitrary, but let's just say you have them. What category of developer tool would you say is most in demand right now in terms of a gap?
Well, I mean, I'm a software engineer, right? So like when I see this prompt engineering, like the dark arts of voodoo kind of, right? Like talking to the Oracle, right? I think we're kind of regressing back 1,000 years or more, like we do animal sacrifices. Like let's sacrifice a black goat, maybe the rain will come. No, the black goat didn't work. Like the white goat maybe will do it. No, the goat doesn't work. Like maybe it's a sheep, right? So like we're very strangely in this pre-scientific era. Like we regressed, right? So like I think we really need to get back to rigorous software engineering around this stuff. So there are things like DSP from Stanford. Again, like this is interesting to me. I'm not speaking for the Alliance, but you know, again, like we hosted some talks like TDD with LLMs, right? So again, I think there is a demand. How do we make this back, like bring it back as a rigorous profession? We cannot throw darts in the dark, right? Like we, you know, like where this industry is going, right? We need some way to make measurable progress and decrease fragility. So I think we need to do a lot of kind of tooling to monitor the stuff. And until we understand, right, how this properly works, we need a lot of tools to give us some assurance of how reliable this stuff. So we need to do a lot of back testing, right? We need to do a lot of TDD, which will give you an assurance that you're moving forward, right? But we also need things like throughput. We need, you know, fast inference. So there is a lot of work to give you an idea what, like Christy was showing, how much does this stuff cost? How much stuff do you need? What do you actually, right? Like there is a lot of questions. So I think we need to inventory everything, and we need to prioritize and make progress, you know, across the board. I don't think this is easy right now, right? Like we're suddenly strange and back strange, like Twilight Zone again.
First, thank you. I think this is a really cool thing and something that we definitely need. I wanted to get your thoughts on LangChain and LlamaIndex. I think both of them are part of the Alliance. They're basically alternates to each other, and they're both local. I thought they were great open source projects, and both of them just raised 10 million, 8.5 million seed rounds. I don't foresee that staying open source. I foresee that going like a Facebook type approach. So yeah, just want to get your thoughts on it, and if you think there's going to be other people who are going to come and fill the void that they're going to leave.
So this is a great question, right? So and I just had interesting conversations with GitHubbers who think of governance about this, right? So we are in a time when companies understand that open source effort is very valuable, right? So your open source software is an important asset. And we see kind of a situation where people are not in a hurry to set up some kind of recognized public governance, such as Apache or LinuxFoundation, right? And so that, being at IBM, we're reluctant to invest in things which do not have clear governance, right? So this is a constraint. And you know, Red Hat obviously is a big part of IBM, which has a lot of experience in developing this project. So we're very happy that Red Hat is a part of this. So we need to work with stakeholders, right? We're basically, I think a majority of these cases, companies are very small, and they just, you know, going ahead and cranking up their open source, right? Like LangChain was 3 people locally, right? So it's not like they're against this. They just do not have the bandwidth, and they need to do a lot of thinking. They need to forge ahead instead of being stuck in kind of legalese, right? So a lot of companies are reserving their options, how to do it exactly. And so we work with LinuxFoundation, Apache Foundation. We have OSI, which is the foundation for open source licensing, right? Which opensource.org, which basically oversees open source licenses. So there is now a big demand. We need to define what open source AI is. Some people now say that actually we don't, it's already well defined. It's just like a collation of code licenses, which is OSI, data license, which is Creative Commons or something else, right? It's like basically, I think next October, they will unveil the definition of open source AI, and then you can, you know, decide if you want to follow this or not. But, you know, some people already see it, they're using lack of the definitions as an excuse to stay close, because if there is no open source AI, we don't know what it is. So for now, we're just going to do whatever. Like when you guys define it, then we'll look at it. So there is a lot of interesting interplay, but if you look historically, you know, the open source solutions like Linux, right? Everything Linux Foundation adheres to OSI licenses, and companies are investing heavily. So recently in Bilbao, telecoms came together behind the standards for open networking, right? So like the hundreds of millions of dollars have been invested in properly governed open source projects. So I think as AI matures, I don't think, first of all, it will go, first of all, Meta is actually very actively looking at how to make it more and more open, right? So they do have research license, but I think the goal for this alliance and Meta in the alliance is to make it easy to adopt, right? They need to solve safety concerns. So we have a safety track, right? We need to understand how do we de-risk this. So this is a concern. Right now, there is a lot of legal uncertainty around this, right? But generally, I think we need to move everybody to open governance, which is understood, which is democratic, and basically there shouldn't be a risk that somebody's going to capture an open source project, change the license, right, and everybody's work will be hanging. Like we've seen these examples. We cannot allow this. So as an alliance, we'll set up a structures that we only move forward. Like we do not regress on open source.
Okay. Is there any last questions? Otherwise, we will let you go, and you can talk to Alexy afterwards. And I have a seed question if you want to ask George what he thinks about current benchmarks, what's missing.